learning world. And then we will keep moving towards MLFlow. This is the main topic of today's discussion. We will be talking about what is MLFlow, why we should be using MLFlow, what's the architecture, how to get started. We'll compare it with another famous platform, and then we'll move towards Charmed MLFlow. And in case you don't know what's that, don't worry, just bear with us until the end and you'll learn more about it. This is a live webinar, so feel free to ask us any questions. I'll make my best to answer to all of them during today's session, but if not, we'll follow back with you as well. As usual, your feedback is important as well. So if you have suggestions, if you'd like to know more about any topic that is not covered, just reach out to us, drop a comment, ask us a question, or don't forget to fill the feedback form at the end of it. That's a statement that is quite obvious. Artificial intelligence is everywhere. If I think of ChatGPT, it might be the word of the year. It reached 1 million users in less than a week, and it feels that it made all companies rethink their AI strategy. But if we're being more pragmatic, there are applications of artificial intelligence in all sorts of industries. If we think of all the cashier from the cash services from the retail stores, as well as all the inventory management tools, retail is heavily benefiting from artificial intelligence. And then we can also think of personalized experiences, all the recommendations that we get whenever we buy things online, that also falls into that. But then I'll move towards financial services, and the card fraud detection is a use case that has been around for quite some time, but we also have credit risk analysis, for example. That's another use case that is picking up and could benefit a lot of institutions heavily. And then I'll move towards telecommunications with self-organizing networks, for example. Then, if I think of smart cities or cities in general, a lot of public sector organizations are picking up on artificial intelligence, are building their projects to optimize the traffic, to optimize the energy efficiency, to improve the safety of different cities. And that is very important. So, yes, AI is everywhere. And it goes really beyond ChatGPT or generative AI, even if that's an important topic that maybe we will be covering in a future webinar. Yet, you might wonder, well, if it's everywhere, why I don't see it? Depending on where you are around the world or what's your job, you might benefit from it more or less, and it's normal. The speed of development depends on geography, industry, skills that are there. But the truth is that building artificial intelligence projects is still challenging, and challenges can be split into four different categories, or that's how we thought about it. And the first one is people. There is a need for a unique skill set, and yet there is a clear skill gap on the market. Of course, universities understand the need of having specialists in data science, machine learning engineers, also the need to cross different industries, so to get experts in financial services or telecommunications that understand artificial intelligence. But the market is still not there, and that's why you see a lot of job offerings on data science. That's why you maybe see very good salaries on that industry. But at the same time, I see universities having entire courses focused on machine learning, data science, artificial intelligence. I see different subjects in universities, in engineering schools especially, that are picking up on that. And I have to tell you that when I was a student, that was not there. It was just optional, and it didn't feel as being such a big priority as it is right now. But moving beyond the skill set or the skill gap that is out there, any artificial intelligence project has a lot of stakeholders. And that is challenging as well because they have different understandings, they have different needs, they have different challenges or agendas at the end of the day. And finding a common ground for all of them can be difficult when you start an AI initiatives. However, once you figure that out and you're happy with the people side, we can always move to the operations side where I have to say that at the moment it always seems that AI requires high maintenance. It's mainly because the landscape or the tooling is still not well connected. There are new projects or new tools popping up every other day. And then also, whereas it's quite cool to experiment, nowadays you have laptops that are powerful enough to do that. When you want to run AI at scale, there is a whole new set of operations that you need to bear in mind as an organization. So having capabilities such as user management is still challenging. I'll move towards now the technology because I touched a bit upon that. And the truth is that it's a fast changing landscape. You see new tools coming up every other day. You see projects being abandoned every other day. And then you almost wonder yourself as an enthusiast, as a professional, and as a decision maker within a company as well, what's the best choice for me? What should I choose in order to ensure the success of my project? Because that is really something that I need, I want. It would save money for my team. It would help my team with operations, or maybe it would make me feel happier because it's a project that I am really curious about. But then also the machine learning lifecycle is still complex. It has a lot of stages as well as a lot of dependencies, and that's something that we need to bear in mind when it comes to technology. Last but not least, we still need GPUs in order, or compute power actually, to perform AI, especially at AI at scale. And whether we talk about GPUs or NVIDIA's DGXs or public clouds, there are costs associated with it that at first sight can be overwhelming. I move towards data because data is the heart of any AI project. If you don't have data, the truth is you won't have any AI project. And often projects work with highly sensitive data, data that could put at risk privacy or the safety of different people. Reason why, whenever it comes to any AI project, we need to bear that in mind. At the same time, depending on the project, there are different data sources from numerical data that stays in a table to text data to images or videos. There's a variety of data sources nowadays that can be used for machine learning projects that can be overwhelming and can be challenging to deal with, as well as the data volume. There are tons of statistics on how the data volume increased over time, and whereas that's great because it means there are more chances to get a successful AI initiative, it can also be challenging for professionals to figure it out how to navigate that side. And then apologies. And then if we think of the AI readiness, there are different parts or different steps. Usually you start locally on your laptop or maybe on a public cloud with initial AI exploration. That's the moment when you say, hey, I would like to have an AI project. I would like to play a bit with it. There is this use case that I have in mind. I don't know. I would like to analyze my costs for the last 3 years to figure it out how I could optimize them. And once you understand how you could benefit or leverage your data the most, you think of how you could do it repeatably and reliably, because otherwise it feels that it's a very manual process that it's difficult both for professionals as well as for companies whenever they want to scale. Often that happens on the public cloud and then or on-prem. Only after that, once you figure it out a recipe to have repeatable and reliable artificial intelligence, you look for the next step on how to run AI at scale. That usually happens on prem, but that's not mandatory. It really depends on each organization and how they have their environment set up. And last but not least, when you want to do or to run AI at the edge, that's a whole new challenge because the hardware there is very different. The requirements and the needs are very different as well. If we think, do we want to do real-time processing or not, for example, is just one example. However, what's interesting here is the different set of tools. You run or you begin your AI journey locally on an Ubuntu machine, for example. But then once you want to start repeatable, or sorry, to begin with repeatable and reliable AI, you need to expand your area or your tools. So from just an Ubuntu, maybe with a Jupyter notebook, you move towards adding new tools. MLFlow is usually the one that is really good for experiment tracking, and that's what we will be talking about. But once you want to run AI at scale again, you need to add new tools in your stack. How do you do that? How do you integrate all these tools, and how do you ensure that actually your work stays the same and can be taken from one step to another? That's a question that it's worth answering or worth wondering as well. However, another important aspect is the open source angle. Unlike previous innovations that happened out there that were really closed source, it used to be very difficult to get to the to get to the bottom of them because people organizations would try to keep them as protected as possible. I think AI as a trend also brought a new revolution into the market because most of the projects are actually open source, which is great. You see an entire new trend of people contributing to it. You see new markets being developed. If you think of of countries such as Nigeria or Ghana, they're very strong with data science, but historically they were not necessarily strong in software development. It's great because it really showcases the power of open source and how much we evolved over time. When it comes to open source, we can use tools at all stages of the machine learning lifecycle, from storing data into databases such as Postgres, MySQL, or MongoDB, open source, why not, to do data streaming with tools such as Spark, then to perform machine learning activities such as training or hyperparameter tuning, experiment tracking as well with tools such as Kubeflow, MLFlow, Superset for data visualization, Feast for feature store, and then also to model deployment. If I look at NVIDIA's Triton, Selden, ONNX, are just a couple, okay, sir, are just a couple of the solutions that we have out there. We can also look at different tools for observability, for example, such as Grafana and Prometheus. And what's great here is that you have so much option as a developer, as a machine learning engineer, that once in your life you don't feel that you are limited because there are no tools on the market. It might be the opposite. On the other hand, there are so many open source tools out there that you might feel overwhelmed. Which one is the right one for me? And we will be answering a question related to MLFlow, when it is right to use MLFlow and what is MLFlow good for, such that at the end of it, ideally, you will know when to choose MLFlow as an open source project for your artificial intelligence project, as well as how to easily get started with it. I will not make it any longer. I'm curious, and I'm asking now the audience who's listening to us, have you heard of MLFlow? I hope so. Or at least if you're an AI enthusiast and you didn't hear of it so far, you're in the right place. MLFlow is an open source platform that is really designed for the machine learning lifecycle. It was started a couple of years ago now, and we'll go through the history of it, but it's also important that it's a very famous project. It's one of the most stable ones, I'll have to say. It has more than 3,000 forks and 1,500 um, 15,000 stars, which really showcases the love that machine learning engineers, data scientists, AI enthusiasts have for this project. And that it's quite nice because it's been around for a long time, so it's integrated with different tools. I have to call out here Kubeflow, Spark, Kserve, but also with different frameworks and libraries. If I think of TensorFlow, PyTorch, Keras, or Hugging Face, these are just a couple of them. But it's also important that it's not just used and loved by people, but also by organizations. Databricks has been, and it's famous for the huge contribution that it made to MLFlow, but they're not the only one. Microsoft, Facebook, Accenture, Canonical are just some other examples, and you can always go on their website to see actually how famous MLFlow is. And it is quite overwhelming if you think that this is an open source project in an area that was not around for a very long time. So let's see, what's the history of MLFlow? Well, it was started in 2018. So it's now a little bit more than 5 years ago when the first release of MLFlow was out there. And if we move quickly to the beginning of next year, in January 2019, we will see something that the community did quite well. A user survey. It really helped the community understand the user needs, the customer needs as well, the challenges that the market was facing back then, such that they built a project and a solution that is designed for those who end up using it. And that was great. That's a habit that the community still has. And I think it's quite nice. Shortly after the version 1.0 was released, and there are exciting features that came out like that, such as improved metric visualization, improved search functionalities, HDFS support, but also stability for REST API, Python, Java, and R, which is great. I think that's when the project really made a difference. But then it didn't stop there. A year later, they integrated with PyTorch, for example, and it's worth mentioning that until that point, they also integrated with Spark. So in November 2022, when the second 2.0.1 was released, also the project announced 10 million users, which is huge. I think it really showed the love that the community has for MLFlow, but also the need that the AI world had for a lightweight, user-friendly tool that can run on any environment. It's easy to get started. It's easy to begin with, but also you can integrate it and use it for scaling your AI initiatives. The second 2.0.1 came with a lot or came at the back of a lot of community feedback, and it really simplified data science workflows in order to deliver innovation and position MLFlow as a first-class tool for the machine learning world. There are different features and improvements that were added, including MLFlow recipes that were formerly called as MLFlow pipelines, but also capabilities such as hyperparameter tuning, classification support, and then better integration with the machine learning ecosystem. I'll also have to say that the MLFlow tracking UI was refreshed back then, and I don't think it has been ever since, but it's really nice and it's very user friendly. That's what I'll have to say. So I'll move then towards September this year, which is actually today we came with great news when we just released Charmed MLFlow. I'm curious, do you know what Charmed MLFlow is? You can answer, or maybe you can ask questions about this topic as well. You might wonder by now, okay, this is a great project, Andreea. It's obviously loved by everyone, but what are the challenges that it actually solves? Well, I have to say, before the MLFlow word, there were different difficulties when it comes to machine learning, and they were really related to experiment tracking. How do you track different experiments, and how do you ensure actually that you're choosing the best out of those, which was very difficult, but also code reproducibility was challenging, and then package standardization, if it came to, or if you think of having it on both AWS and Docker Hub, that was a complete challenge. And last but not least, model management. You don't build a model once and that's it. The truth is that you build more than one model, and how do we ensure that you get the right management of those? It was a challenge, and MLFlow solves all these challenges. So I won't make it any longer. I'll have to say, why should we use MLFlow? Well, it's cool, and that's nice. But the truth is that actually MLFlow is very helpful for reproducing results, and machine learning projects usually start with simplistic plans and tend to go overboard, resulting in an overwhelming quantity of experiments. It's both because of curiosity, but also desire to get the best performance. So manual or non-automated tracking implies a high chance of missing out on finer details. Machine learning pipelines are usually fragile, and even a single missing element can throw off the result. The inability to reproduce results and codes is one of the top challenges in for beginners with machine learning. So MLFlow really changes or helps with this, I'll have to say. Then it is really environment agnostic. Uh, it gives flexibility across libraries and languages. And it can be accessed through a REST API, a CLI, but also there are a bunch of programming languages that are available for convenience, including Python or R. I'll have to say that it's easy to get started. Uh, I, I had in the past, and I still run often webinars about Kubeflow, and Kubeflow is designed as being a tool to run AI at scale. And whereas it's great for that, I don't think that if it's the first time when you're touching a laptop or a machine to build your first machine learning model, it's the best solution. Whereas MLFlow, I think it's great. If you use MLFlow with Jupyter Notebook, you really have a seamless experience. By now, you have plenty of videos, plenty of tutorials on the internet on how to use it. I just published a video on YouTube on how to install MLFlow in less than 5 minutes. Actually, I have 2 minutes and 40 seconds. And I think that's one of the assets that MLFlow has, especially for beginners, but also it works anywhere. It's lightweight, you can deploy it on your own laptop. There's nothing that could break your laptop or make you struggle with it. But then it's also integrated with machine learning tools. I already mentioned Kubeflow, I mentioned Spark, but that's not all. In general, MLFlow benefits from wide integrations, and I think that's important that's an important factor to consider when you choose your machine learning tools in general, because you don't want to work in isolation just with one tool, because sooner rather than later you will have needs to or you will need different features that MLFlow doesn't have, and then what do? You start it over again with another tool that might be both frustrating as well as time consuming. Last but not least, MLFlow benefits from enterprise support as well as managed services from different companies that distribute the project, which is important as well, especially if you're part of an organization that uses it or you consider adopting it within your team. I'll keep moving forward on what is MLFlow. I'm not sure. Do you know by now what is MLFlow? Well, the truth is that MLFlow is an open source project or an open source platform that is used for managing workflows and artifacts across the machine learning lifecycle. It has built-in integrations with many popular machine learning libraries, but can be used with any library, algorithm, or deployment tool. It is designed to be extensible, so you can write plugins to support new workflows, libraries, and tools as well, which is nice for those who are more advanced or work in very specific industries. I can easily think now of oil and gas professionals or people who often work with maps, like from the cartography world, who might need to write their own plugins. And that's great. They have this possibility and they could benefit the most out of this tool. So I'll move towards the architecture a bit or the main components. MLFlow has four more components that are designed to support the machine learning lifecycle. MLFlow tracking allows you to track experiments, to record and compare parameters and results. It's what we often call experiment tracking, and I think that's really the key part that MLFlow offers. MLFlow models allow you to manage and deploy models from a variety of machine learning libraries to a variety of models serving inference problems. MLFlow projects allow you to package machine learning code in a reusable and reproducible form to share with other data scientists or maybe with your friends. So you're able to transfer actually your work to production. This is really important in an enterprise environment, but also it can be helpful if you want to collaborate within a team, for example, at university. MLFlow model registry is the last component that I mentioned, but it doesn't mean that it's the least important. And it allows you to centralize a model store for managing models full lifecycle stage transition from staging to production. With capabilities such as versioning or annotating. It is, I think, the capability that made the biggest difference for me when I learned about MLflow, because it's cool to build machine learning models. It's very rewarding to do that. But then how do you keep track of all of them? It often becomes a mess and it can easily turn into a very frustrating activity. It's also the component that it's mostly integrated with other tools. So it is worth looking at it. But now I'll take them one by one and talk about them. Also, if you do have more questions on how to use them, feel free to ask me in chat with no problem. So MLflow tracking is really used to track different pipelines parameters, as I already mentioned, such as metrics, hyperparameters, feature parameters, code versions, or other artifacts. The logs, if you're wondering what they are used for, they can be used to visualize or compare the results between experiments, users, or environments. They can be stored both on any local system as well as on remote servers. They are really powerful because they give you a path to return to a previous activity in a really reproducible manner. So I'll move now towards the second component, which is really MLFlow Projects. And you might wonder, what is MLFlow Project? Well, it offers a convention for packaging or structuring your machine learning projects and reusable project codes as well. Fundamentally, a project in the machine learning world is a directory along with a descriptor file that defines the structure and dependencies. And you have to bear in mind that usually machine learning projects have plenty of dependencies. Additionally, on using the MLFlow API in the project, MLFlow will automatically remember the parameters or project details, which actually accelerate and saves time for teams or people who are actually using it. Let's move towards the third component, which is MLFlow models. You might guess already, it really refers to machine learning models. And with this component, ML models can be packaged into different flavors. In our case, by my definition, a flavor is a format or structure such as a Python function, and the descriptor file defines it. The ability to package flavors enables the model to be used across a host of downstream tools and platforms, including Docker or AWS images, AWS SageMaker or Charmed Kubeflow. So it makes the model lifecycle easier to process and manage. It also gives the flexibility that I was telling you about, actually, it gives you the flexibility that I was telling you about, that you can run on different environments. I'll move now towards the last component, which is MLFlow Model Registry, which acts as a core and enable APIs, user interfaces, and centralized model storage. It aims to govern the machine learning pipeline, so tracking model lineage and versioning capabilities. It's really the place or the capability that helps you manage your models. I see I'm already getting some questions. Thank you for those. Keep asking them. At the end of it, I'll take some. And I would like now to go towards the key concepts that MLFlow has, and there are two of them, runs and experiments. I think for those who are familiar with MLFlow, you might know what an experiment is, and it's really the primary unit of organization and access control for MLFlow runs. All MLFlow runs belong to an experiment. Experiments let you visualize, search for, and compare runs, as well as run artifacts and metadata for analysis in other tools if that's what you need. An MLFlow run, on the other hand, corresponds to a single execution of the model code. All MLFlow runs are logged to the active experiment. If there is no active experiment set, runs are logged to the notebook experiment. To log your experiment results to a remotely hosted MLFlow tracking server in a workspace other than the one which you are running the experiment, that's also possible, but it does require some additional activities. I would always recommend or encourage you to actually check the um, the documentation that MLFlow project has. How do you use MLFlow? I'm not sure by far. Do you have any ideas on how to use MLFlow? Here I mentioned some of the personas that might end up using MLFlow. Data scientists usually track their experiments using the tool. MLOps engineers compare the performance of different models. Machine learning engineers start locally and often structure their projects. Machine learning teams integrated with other tools depending on the use case, such that they are also able to scale their AI initiatives. AI enthusiasts can contribute to the Upstream project. And it's something that maybe it's not so obvious, but I already mentioned that MLFlow is an open source project and it grew so much. It developed in such a nice manner, really, because people contribute to it. And as in Canonical, we have open source in our DNA. We love being open source. And if there is one call out that I would like you to do is that you can use MLFlow, but you can also contribute to the project. Even if you might think that raising an issue is not a big thing, it actually is a contribution, and you have to acknowledge it and to always think of it. I'll move now towards MLFlow versus Kubeflow. A couple of months ago, we actually ran a webinar about it together with Maciek and Kimonas, who are my colleagues. You can always search for it if you want to see the entire debate. Kimonas is a big contributor to the Kubeflow project. Maciek is a big MLFlow user, so they really had interesting opinions. And their conclusion was, hey, Andreea, you're trying to compare apples with oranges. That doesn't make sense. So let's try to get into more in details. But for those who are not familiar with Kubeflow, Kubeflow is an MLOps platform that is designed to develop and deploy machine learning models. Charmed Kubeflow, which you see here, it's really Canonical's distribution of the Upstream project. It has different components. It's really a suite of tools. So you can use Kubeflow notebooks, which are very similar to Jupyter notebooks for training. You can use Kubeflow pipelines for automating, but then you can also perform model serving and AutoML. It's a cloud native application. It runs on any CNCF conformant Kubernetes platform, and then you can run it on any environment, whether it's public or private cloud, and it can even support hybrid or multi-cloud scenarios. So this is the platform that is often compared with MLFlow. And I'll just cover here a bit of the machine learning lifecycle to quickly showcase that actually Kubeflow and MLFlow, it's strange to compare them because they cover different needs of the lifecycle. MLFlow can work as a model repository and it's good for collecting logs, but at the same time, Kubeflow is very famous for its pipelining capabilities. So, except for the fact that I've been comparing apples with oranges, the truth is that Kubeflow is really to deploy and manage models on Kubernetes and is designed to run AI at scale. And then it has the pipelines engine, which is, I think, the height of what Kubeflow is. At the same time, MLFlow is used for tracking machine learning model training process and parameters. It's used for deploying models into multiple platforms, as we already discussed about Docker Hub and SageMaker, for example. And then it's really used for packaging reusable data science code. I kept nudging my colleagues back then, how do they work together? And the truth is that we integrate these two tools, what is called Charmed Kubeflow and Charmed MLFlow. They are integrated together such that we get the best capabilities from both platforms. But I will not insist more on that and rather encourage you to look for the webinar where my colleagues are really experts in the area. They're very technical as well, have been talking about it more. It's also a sneak peek on where do we think that actually the future of Kubeflow and MLFlow stands. What is charmed Kubeflow? Charmed MLFlow. Well, it's a charming tool. That's why we call it charm. And that's probably the lamest joke. I keep doing it. I don't know if people like it, but I like it. Charmed MLFlow it is Canonical's distribution of the Upstream project. I already mentioned that Canonical has open source in its DNA, in our DNA. So Charmed MLFlow is similar to the Upstream project, an open source project that benefits from enterprise support. It can run on any environment. It's really lightweight, but then if we integrate it with Kubeflow, for example, we can run it at scale. But then it also has faster integration installation, which is quite nice. I would encourage you to follow the YouTube video that we had. And this is the most common question that we get in Canonical in general. What's the difference between the charmed products and the upstream products? And here it is. Well, the truth is that charmed MLFlow has all the capabilities that the upstream project has, but we add a couple of things on top. On one hand, we have observability capabilities of the infrastructure, which is very important because you can monitor and you can observe, you can get alerts about your charmed MLFlow deployment. You can see how many resources it uses and so on. And we use that by integrating with Grafana and Prometheus as part of Canonical observability stack. But then we also do bug fixes and security patching. And if you think of our promise to offer secure open source software, it doesn't fall short for machine learning tooling. But then I'll move towards more the enterprise side of it, because we do offer enterprise support as well as tools integrations. I already mentioned Kubeflow, I mentioned Canonical observability stack. I'm happy to add Spark, for example, or Kserve as other two options. And last but not least, we offer managed services. And we are getting close to an end. But before we get to that, I will start scrolling to some of the questions, actually. I see one of them being very simple. If the presentation will be available to download, I'll have to say that I think so. I'm happy to share it with my colleagues from marketing if it's possible. Then I see a question if MLFlow is a good choice for monitoring model performance production, or will the increased scale pose a problem? Well, I don't think that MLFlow as a project is designed to perform model monitoring. I would rather suggest using solutions such as Selden, for example, or Kessler for model monitoring. They are integrated, or they are part of what Kubeflow is nowadays. And I think it really helps you build a cohesive solution where you benefit from the best of all the tools. So you get experiment tracking usually with MLFlow. You can build and automate you can build models and then automate pipelines with Kubeflow, and then you perform model monitoring or model performance monitoring with tools such as Selden, for example. You can always do model deployment with Triton or Selden as well. You can run serverless with cases, and these are just some of the ideas. It always depends on what the use case as well, and what's the industry, or what are the needs, what's the hardware that we are using. I see a question if MLFlow can work on NVIDIA Tau Toolkit. I'll have to say that I didn't check that yet, but I see no reason not to. However, I'll check before saying anything. Can MLFlow be used to automate and optimize training pipeline, including feature like distributed training and hyperparameter optimization? The short answer is yes. However, if I'll have to be honest, I think this really falls into what training AI at scale means. And this is for those kind of activities, we often recommend charmed Kubeflow. You can perform activities such as hyperparameter tuning. You can run serverless workloads such that you optimize the usage of the hardware underneath, and then you get or you benefit from MLFlow for activities such as experiment tracking. I see a question related to comparing MLFlow with Kubeflow. We already discuss that. Then we see, I got a question if Charmed MLFlow is the evolution of MLFlow or if it's another rebuild. I think that's a very good question. No, Charmed MLFlow is really Canonical's distribution of the Upstream project. It is fully open source. It has the same capabilities as the Upstream project, but additionally, we added a couple of features in order to enhance it and make it easier to use, especially in an enterprise environment. It integrates with different tools, and then it uses what we call charms for packaging as well as Juju for automated lifecycle management. These are the main differences that I can tell. What is the difference between Charmed MLFlow and just MLFlow? I think that's something that I already covered. I see a question if MLFlow will support Julia in the near future. I think this go back to my advice to everyone to actually contribute to the project. If this is something that you think it would help you, I suggest you raise it to the community directly. You can either go on their GitHub or join their Slack channel. Check it out when there is a next user survey and try to raise this kind of opportunities because no one will actually know that you have this need if you don't raise them up. And it takes one small step to start contributing, and then you realize how rewarding it is, and you might find yourself actually contributing. So, to keep it short, I suggest you actually ask the community directly because they know the roadmap, and that's where you can actually get things added to the roadmap. I'm being very conscious of time. I've been talking for over 40 minutes now. So I think you got it so far. You should use MLFlow to get started with your AI journey. It's an open source project, so you can both use it and contribute to it. And then it is really it is useful if you want to manage machine learning models, reproduce experiments, but then you can scale with it by integrating with other solutions such as Kubeflow, Spark, and build an end-to-end solution that can fit your use case. And it's worth mentioning that there is no such a thing as in an out-of-the-box AI solution that fits all use cases because they're very diverse. And depending on compute power, data sources, data size, security needs, you might find yourself in need for other tools. If you're looking for enterprise support as well, you can always get or go for Charmed MLFlow. And bear in mind that you can run it anywhere from a laptop that has Ubuntu on it to all the way up to running it at scale. There's nothing that could stop you. So Charmed MLFlow is now available actually. We launched it today, a couple of hours ago, depending on where you are around the globe. It was midday UK time. I would like to really invite you to go on ubuntu.com/AI/MLFlow and try it out. Share with us your feedback because that's what we love the most. That's why I love being part of an open source company. I can easily interact and get in touch with users who have feedback for me, and that's the only way that we could make our product better. And before we wrap it up, I would like to also highlight Canonical AI Roadshow. It's really a series of events that takes us around the globe, from Amsterdam to Dubai, from Sao Paulo to Chicago, from Austin to Bilbao. We keep moving around to talk about open source, artificial intelligence, large language models, MLFlow, Kubeflow, and how you can actually innovate at speed with open source AI. Feel free to meet us at any of these events to talk more about your own solution, your own challenges, and how we could actually help you. I'm not sure. There is another question before I wrap it up. As a DevOps enthusiast, would it make sense to use MLFlow in a project pipeline, including machine learning and AI? It depends on the use case. I'm tempted to simply answer yes, but it usually really depends on the use case that you have, as well as the challenges that you have. MLFlow is really good to get started. It's easy, but I don't want to say yes without knowing your use case. So if you'd like to follow back on the use case, I'll happily go back to this. Okay, thank you very much everyone for joining me, for asking questions, for being part of what Charmed MLFlow is nowadays. So don't forget to install it. You have a video on YouTube to try it out, to share with us your feedback as well. Have a great day or a great evening, depending on where you are around the world. Bye bye.